Good day, folks. I'm excited today to release my modifications to the Maxwell equations and solutions to the unknowns. A little bit of background on how it's all started. About a couple months ago, I was trying to find some novel relationships using the original Maxwell equations, and I was basically, I talked about this. I used some Python programs to try and calculate some relationships. So I revisited the original 20 Maxwell known variables and plugged that in. And basically, with the help of the computer, it tried to find some relationships with the tensor map, basically. Once I started finding potential matches, I started doing the research one by one and plugging the values in. And as it made more sense, I built up upon that and elaborated. And then as we found the new equations, modified the Maxwell equations to accordingly work with those new relationships without screwing everything else up, right? So everything has to balance at the end, basically. So it was a bit challenging to make sure, well, if you satisfy essentially one side, you got to satisfy the other, right? With the help of the computer, of course, it became a practical task. Anyways, I thought it would be impossible, but I started finding matches, and then I had to verify to make sure, I was actually onto something and it made sense. And from there on, we found a lot of new novel interactions, and I don't know where to start here. This is something that would, it'd take me a week to properly cover from start to finish, as you can see from the document yourself. It's really intensive, and I'm probably going to miss a few points here, but I'm going to try and do my best, folks, to summarize it in English what this all means. So essentially, folks, one long story short, we're basically all on the right track with our various projects we've been doing. So essentially, with the hints that Tesla left us and the other researchers in the field, along with our own experimentations, and what Tom Bearden was saying with what he felt the models need to be modified with his theories. So basically, we've been able to experiment with crude concepts like resonance and scalar waves and wave mixing and all of that stuff, and even Bedini's and Tom Bearden's nonlinear elements and all of those breaking the symmetry ideas. But as Bearden states, there's no updated model to support. It's all like little pieces from here and there, right? So until, he suggested that we have to revisit the Maxwell equations and everything else and update the models accordingly. So essentially, that was my goal, to do that, as Tom Bearden stated. And essentially, by doing that, I was able to essentially confirm many of the interactions that we're already doing. But now, at least, what happens is we have a basic, real theoretical, mathematical framework behind it. So it gives us a clearer insight now on what's happening and what specifically needs to be done to enhance the conditions. And specifically, it also gives us an idea of, using these methods, how much of this vacuum energy we're able to tap into, okay? So I start off by essentially getting into the basics of the Maxwell, and we start looking at it and seeing if the original Maxwell equations actually do pan out. And they essentially do, which is a good sign, so we can move on, because the formulas are, so we essentially verify that everything in the original sense, right? But we've got to remember, folks, and everything, is in its unmodified form, is assuming a perfectly symmetrical system, right? So we move on to, which may seem disappointing, but you have to remember when you read this, the context is very important in math. It might be deceptive at first. So that's why you got to really pay attention to the wording. So someone who gets to like page 4 may get disappointed with the findings and say, no, but that's not it at all. It's actually good news. And what I'm going to say is, we first thing is we look at the existence of the magnetic monopoles, the magnetic dipoles, the open dipole that Tom Bearden describes being a continuous flow of energy. Now, with the unknowns filled out, and once we start plugging in the values, what this confirms, anyways, we're starting off somewhere, right? So we're starting off with a symmetrical system. So in a purely symmetrical normal system, unfortunately, which is not really unfortunately, it's what we basically already knew. It just gives us the framework that tells us that in its traditional sense, magnetic monopoles don't exist. And the reason for that is even the magnetic fields, if you look at a magnetic rod, a normal N on one side and S on the other, the magnetic fields come out and they decouple each other. The math in the solutions show us that this is considered a magnetic equivalent of a closed loop system. So it helps us determine an answer and potentially calculate how long a magnet would last on its own, because even if it's disconnected, as long as it couples between its N and its S, there's always a closed loop. And the mathematical framework basically proves that. But we move on from with the findings and elaborate and then move on to broken symmetry, and that's when things get interesting. And there's no rules, folks, that say that in a symmetrical sense we have to stay symmetrical. We don't. Howard Johnson proved that with his magnets by modifying them. You can break the symmetry in magnets, and then all of a sudden you can switch them, you can neutralize the fields, you can deflect them. So with a little bit of creativity, what I'm getting at, folks, is we're able to artificially induce the equivalent of magnetic monopoles. So we can engineer them essentially, and perhaps even some novel or I don't say unnatural, but some phenomena maybe could trigger it in the air or something. Some conditions, very oddball, but who knows, right? But the point is, in normal circumstances, looking at it in a balanced system is a no-go. But as soon as you break the symmetry and the math shows that, everything changes and then it becomes possible. Now, moving on with the magnetic monopoles, what the extended equations tell us is if you were to build a closed loop, which is very interesting because traditionally a closed loop system means that it's going to eat up its power eventually, right? But the math seems to indicate that if we include magnetic monopoles strategically placed all along the closed path, we can induce a gain. So leave it at that, which is very interesting because, but it's always a little bit more complicated with magnets, right? So you could either do the Howard Johnson or mix and match different methods. I've also found something interesting. I don't know if everyone's seen it, but they have these at some university, I believe. I saw that a few months ago. The equivalent of a magnetic resistor, which is basically a shielding plate with little holes and lines, and it rotates, and the rotation creates the switching, and the patterns determine how much of the magnetic field between the two magnets can pass through. So they can switch that field and add the resistance value they want. But of course, folks, right, some energy is required to spin that, right? So sort of back to the drawing board for that method, but someone could power it with wind probably. So maybe an idea there for a novel way of switching magnetic flux. So with that said, it elaborates into that and gives us the details. And it supports the idea that it's crucial that we break the symmetry, which we already knew, but it gives us the framework to that. It confirms that it's crucial to add nonlinear elements to our systems, which we basically already knew indirectly, but it gives us the precise framework and the actual theoretical mathematical model with the Maxwell modified equations. And this is very interesting because, like I say, it suggests that not only Maxwell rules need to be, the model needs to be revised, but even some of the Einstein and everything else. But I can't do all of that. But as you see in the report, I've actually had to modify a few external models to be able to accommodate for this. So, but naturally, it's not my job to rewrite the whole science. But this is where Tom Bearden is right. All of our models literally require a rehaul and a complete redo, honestly. So, but we got to start somewhere, right? So hopefully by cleaning up the Maxwell stuff, it's a start, right? So, with that said, I learned a few things too through the new interactions. Now, by including scalar torsion fields and mixing that with vector potentials, leads to very interesting interactions. In other words, energy gains, folks. It's there. But again, good news and bad news. The models suggest that even though the vacuum is vast and has this enormous amount of energy, right now the only known methods in our theories and in the way we know we're limited in our dimensional plane, the only way to interact with these virtual state, the virtual dimension, so to speak, is through the quote-unquote zero-point fluctuations in the waves that we interact with. So what the model suggests is that even though we can interact with the vacuum at any given wavelength, it's going to be for a very small period of the total cycle. So in other words, if you were to do something like try and calculate the RMS value because it's a wave, you'd end up with basically zero. But it doesn't mean you don't have a gain. The instantaneous when that moment where it interacts can be a very, very vast burst for that small moment. So the point is, what the calculations are telling us is we're on the right track to switch and use resonance, but we need to go way up in frequency, RF, maybe borderline microwave, because the whole idea is the faster we can switch that wave, the more interactions with the vacuum in a second, so more of that 0-point opening we have to interact with, which then equals to more energy gains, obviously, with the mathematical framework that demonstrates and details why that is the case. So what the mathematical framework modifications tell us is at the end of the day, folks, with the modifications and the unknown equations solved and taken into considerations, it tells us, which is very interesting because we always try and open the loop to try and get a gain, which is a good insight. But it hints at the possibility that also closed loop systems can be self-sufficient through the environment if properly configured. So that detail there is new to me because I always looked at the open loop concept. This framework hints at essentially an equal under good circumstances, a closed loop system that could very well act like an open loop system. So that was very interesting. That was a takeaway for me, something new to consider. And the interactions are a little bit new. We're on the right track, but what happens, folks, is the models tell us now that it takes more than just a scalar wave. Like, we suggested having a scalar transmitter and a scalar receiver, and we mix the scalar wave and we get an energy gain. It takes more than that, you see. Yes, the scalar wave can interact with the vector, but what happens is the scalar needs to carry a modulated time variant field. So in other words, if we want to interact with 60 hertz energy, to maximize the interaction with the vacuum, we need to put a high frequency carrier, let's say, 900 megahertz scalar, so the phased array, 180 degree kind of deal, scalar wave, but it has to be modulated with a 60 hertz traditional field. So it's going to carry on the 60 hertz time variant field within its scalar wave. When that interacts with your vector, the sums add up, and then you get your energy gains. So what it means is we need to mix the scalar wave with a traditional field and also have a traditional field like a small inverter at the receiver end with 60 hertz that could also interact with the incoming 60 hertz, and through mutual resonance they will resonate and amplify, and you'll get a net energy gain. And that's what the mathematical models are telling us now. But there's a but. Even though we can tap in this way, the way we're doing it, this is the only known method. So there probably, as we get more into it, there might be novel interactions. But this is basically the least the most inefficient way of doing it. So it's like looking at it, folks, solar, the sun being this huge reservoir of energy, but we use solar panels, which are super inefficient. But who cares, let's say, if we're only getting 1%, because that 1% is free to us anyways. Essentially, this is how, with our interactions, or interacting with the vacuum, it's all supported in the models, but the coupling efficiency is very low. But there's so much in there that it gives us a gain once we work with it, if you get where I'm getting at, right? As a matter of what you have to put in yourself money-wise for the output. So you're getting the energy from somewhere, obviously. So it's not just poof, right? So that's what the models are saying. And unfortunately, which again, not unfortunately, it just puts it in the perspective that what it tells us is it's not just specifically magnetic monopoles on their own, scalar waves on their own, non-linearity on its own, broken symmetry. What it tells us is we have to integrate all of these systems into one. And when you do that, in theory, a closed loop system could become self-sufficient from the environment. And the issue with that is it will sustain itself, but only be able to provide a little bit of additional output. So what that means is, crudely speaking, let's say the device is taking 100 watts to operate. It'll self-sustain its 100 watts and maybe give you 2 watts output more. So it's perpetual in a sense, over unity that you get a little bit more in efficiency, but not massive gains. And this is where it ends with the Maxwell modified and solved equations, as far as I could take it with that. Now we know we can extend. There's never an end to how much you can extend into this. So basically what this tells us is, once we get to this point, if we want to have more than just a few watts of output, this is where you got to introduce Tom Bearden's phase conjugate time reversal correction, where we include the elements of nonlinear optics to correct our waves, so we are able to achieve massive gains without loss through resonance and whatnot. So again, stuff that I talked about earlier just didn't have a clear mathematical model to say, here, this actually works with Maxwell. Now, with this report, we sort of do now. So this is basically what hopefully a good contribution anyways. Summarizing it up, it basically tells us, like I said, we're all in the right direction. A few things that I didn't know, like we can operate closed loops under certain circumstances, and specifically what we needed to interact the scalar with the vector to have energy gains. You need to create that time varying field modulation in the scalar as information, and it has to interact with another regular wave. Then you get an energy gain. So I encourage you, if you're like all of that technical stuff, it's all in there. It's about 100 and it's over 100 pages anyways, and it can get very overwhelming. But I try to summarize it as much as I can, and basically telling us what we need to do, or what direction to focus in to maximize what it is we're already doing, folks. So bravo to all of us. I have my ways, some others have their ways and their strong points. Some people like exploring wave phasing and Tesla coils, while others are into the power cells. Essentially we're all on the right track, folks. So just a few tweaks here and there, perhaps with the new findings there, it gives us more of a concrete path instead of being, brute force with it all. Let's try this, let's try that. We have a more direct this path. This is what we need to do. These are the conditions you're going to get. This is the gains you can expect. Don't expect much more than that, But we can elaborate with that and build multiple stages and stack them up and everything, right? So it may be the end of a new beginning, essentially. So with that said, folks, always looking forward to your comments. And until next time, thank you.